Good afternoon, all of you. This is class 11th units and measurement as per CBSE syllabus, and with this video we are sharing for education purposes only on behalf of Ambition Vedic classes. In previous class we have studied what are the different types of errors. Some are systematic errors and some are random errors. While doing experiment, many a times we commit mistake in taking the readings from the instrument, right? So that we have discussed in the previous class. Such instrumental or reading error or man-made error, we call it as parallax error, that we have discussed in the previous class. And two more important types of error which we will face in the laboratory are zero error and least count error. That also we have discussed. Zero error is basically the setting of the instrument is not aligned with the zero line. Then we call the readings from the instrument as zero error. Error is nothing but the fluctuation or the measurement error that we have done. Instead of 5, if we are taking a reading of 5.034, so that 034 is known as error. So error is either excess or less. So if the value, absolute value is 5, then any value which is measured more than the absolute value, it will be erroneous. And any value which is measured less than the absolute value, absolute means the main value, then again it will be erroneous. So error is basically a part of experimentation. Right now I am not very sure, but if you people have been to the lab and if you have tried to take some reading, note down some measurement, yes, probably in 10th standard you would have done, maybe 9th also. So then you would have seen that your reading and your friends reading are coming very differently. Okay, so that we have discussed, and I hope all of you will remember these three types of error. One is known as parallax error, that is the way of looking at the instrument and noting down the value. We should always look perpendicular to the scale or the value which we are planning to measure. Then least count error depends on the instrument itself. If the instrument cannot read in very precise manner, then that instrument will always produce a least count error. We have discussed in the previous class the number of divisions which are present on meter scale or on the vernier scale you will see in the lab. So there is a huge difference. There is a difference between the measurement of a normal scale and experimental scales. So these three errors everyone has to remember: the parallax error, least count error, and zero error. Now in today's class also we are going to study about these errors only and how to avoid these errors that we will see. So let's start. Number one, first thing is mean. How to calculate the mean or the average value, we generally call it. In general terms we call it an average. So for example, let's say in the lab we have to take some 10 times or 20 times reading. So 20 times reading, and these readings are taken in order to avoid the error in the result. You're getting me? So what we do is, instead of taking only one reading of some instrument or some apparatus, we do the process repeatedly, 3 times, 4 times, sometimes we also go for 5 times or 10 times. More the number of readings, more closer or more the lesser the error will be in that reading or in that particular value, which you will see in the laboratory also during an experiment. So what we do basically is, if we have taken 10 readings and all the 10 readings are fluctuating here and there, little bit less, little bit more, so in order to avoid the problem in the reading, we take 10 readings and we find the mean of it. That means we will add all the 10 values and divide by number 10. So that is what is known as a mean. So from the mean we find out how much values are moving are less and how much values are more. That is known as a deviation. Okay, so mean always tells us what was the deviation or fluctuations in the value. Now what does this word mean? Basically, mean is nothing but sum of all the measured values. Every time we have taken the reading, we will obtain a value. Okay, so adding all the values divided by the total number of readings. If we have taken the same value or read the same value 10 times, so then we have to divide it by 10. If 100, which is very rare, so then we have to divide it with 100. So we have to add same value. Let's say for example, if we want to measure length of a pencil, so first time we took a scale and we measured the length of a pencil, it was 5.5. Second time we measured the same length with a scale, again we get 5.4. Then third time we also measured, fourth time, five time, likewise 10 times we have measured the length of the same pencil. So we will have 10 different values. Okay, in order to get the exact value, what we do is we add all the values obtained in total 10 readings and we divide by the number of readings. So 10 times we have done the reading process. Then this is how mean is obtained. So a1, a2, a3 till n. N means basically how many times we have done that reading. So all the values that we have obtained in all the readings, addition of that divided by the total number of times we have took the reading. That is what is known as a mean. A common example is a simple way of writing this is this. So here you can see this AI, and this sign is known as summation. Summation means addition of many values of A, addition of n values of A. So here you can see I, and there on the summation sign you will say I is equals to 1 to n. That means addition of n values of A. So for example, this can be written as A1. If I is equals to 1, this will become A1. If I is equals to 2, this will become A2. And if A1 I becomes 3, this will become A3. Okay, so summation indicates always addition. Okay, and these are called limits starting from 1 to n. So from 1 value to n value, all the values that we have taken, addition of that value divided by the total number of readings that we have taken. A very simple example we'll take. For example, let's say we have measured some value. First time it was 5, second time 7, 8, 9 and 6. So total 5 times we try to find out a value using a scale. But as you can see, each value is different from the previous reading. Okay, then how to find the exact value which is having no error? Here the error could be increasing or the error could be decreasing. The value could be less than the actual value and values could be more than the actual value. And in order to avoid the excess value and less value, what we do is we add all of them and we find out the mean like this. So 5 plus 7 plus 8 plus 9 plus 6 is 35 by 7. 5 is 7. So the length of the pencil will be very close to 7. But as you can see, 5 times we try to measure the value and every time we are getting a different value. This is what happens in experiment during the lab also. You will find out. So first thing, I hope you understood how to calculate mean or the main value or averaged value of a certain instrument or reading. Fine. Then the second term is finding the exact error. So what do we do is we can, once we find out the error, how much was the error in my calculation, we can subtract the error from the main calculation, or we could also see how correctly we have measured the value in the laboratory or experiment. So second important thing is absolute error. Whether my readings were good or bad, that we find out using absolute error. So what is absolute error? It is the magnitude of difference between every value that we have measured and the true value, or simply we can say the mean value. Okay, that is what. So the true value, that means if we have calculated the value of A, difference between the individual measurement and the true value. What was the actual value of that measurement. So here you can see, for example, the error in measurement of A, the first reading that we obtained for A is A1, but after completing the experiment we found that the mean is coming different. Okay, remember this delta A value could be negative also. The answer of delta A could be negative as well as positive, but we always take the value and not the sign, magnitude of delta A1. So this is the absolute error in a first measurement, absolute error in the second measurement, absolute error in the third measurement, and every time that we are going to take measure, we can take the every value, we have to take each and every value, and then we have to subtract the mean value from that. It could be less, it could be more, but see, remember the errors are always positive, so we have to take always the magnitude. I hope everyone is getting through. Magnitude of difference between the every value that we have calculated minus the mean value that we are going to calculate at the end of the experiment. That is what is known as absolute error. So absolute error in A1, A2, A3, A4, and still N. Here it is A3, but it should be actually N. That is what it is. So then, because we already know now absolute error, there is something called mean absolute error, right? So what is mean absolute error? These errors gives the closer picture is how much wrongly we have measured the value, how much mistakes that we have committed while taking the reading of a value. When you go to higher classes, this is what we do there during experiments. Okay, so this is very important, and it comes in entrance exam and all the exams. Fine. So arithmetic mean of all the absolute error is called, it's very sorry for this, is called it mean absolute error. So like we have seen what is mean. Mean means we have seen that every reading that we have taken, the sum of all the values and divided by the total number of times we have taken the reading here. And then we have also seen what is absolute error. So take every absolute error and add them together and divide by total number of readings. So for example, like this, if you see, so this is the absolute error in first, like we have done the exactly mean. So mean is to find the exact value, but here mean absolute error is to find the exact error. You're getting me? So mean of what? Absolute error. We know what is mean, how to calculate mean, so this will become easy. So this is the absolute error in the first value, absolute error second value, absolute error in third value, and so on and so forth, divided by the total number of readings that we have taken. So what we did in previous case, 10 times we have taken the reading. So here there should be 10 values. So error, absolute error in the first reading, absolute error in second reading, plus third, and every time we are going to measure some, do some experiment in the lab, this is what we have to do. Summation of all the absolute errors divided by the total number of readings. That is what is known as mean absolute error, which can also be represented mathematically like this. So like I told you, summation means addition of many values of the same variable. That is what is known as a summation. If you people are interested, many of you will be interested in computers or coding or computer science, so there you will see we use mostly these kind of symbols. So this symbol is known as summation, and summation means addition of all the values of A, or absolute error of A in this case, which is starting from 1 till the last value which we have taken. Okay, so this is whole thing is known as a mean absolute error. Okay, and then importantly, next error is something called relative error. What is relative error? Relative means always in comparison to or compared with something. So you can see here it is the ratio. Ratio is always a comparison. Numerator divided by denominator. So 10 divided by 2, the answer will be 5. That means 5 is 2 times 5 times of 2 is 10, and exactly that is what it is. So here again, relative error is nothing but comparison with the denominator. The ratio of mean absolute error, so mean absolute error will be in the numerator and then divided by the mean value of the total quantity measured like this, which we have seen. So this is what is the mean value. This is the mean absolute error and the second one is the mean. These two values we have seen. This is how we calculate mean absolute error and this is how we calculate mean. If we divide both of them, what divided by what? Mean absolute error divided by the mean value of the physical quantity measured. Okay, so that means numerate this value divided by the second value. That is what we call as a relative error. So delta A mean out of total 10 readings, divided by the mean value of all total 10 readings. We are going to solve some numericals on this in next class, so please pay attention. So this kind of a error that we are going to calculate is known as relative error. In comparison to the mean value, how many times the mean absolute error is known as relative error. And then if this relative error is multiplied with 100, it is called percentage error. Okay, so a percentage error here is relative error expressed in percentage. So if we express some value in percentage or some error value in percentage, then it is called as percentage that error value, or this should be percentage relative error, or sometimes we also refer it as percentage error. That is what it is. Then so this is what we have seen. Relative error is nothing but the ratio of mean absolute error divided by the mean value, the averaged value of this parameter. And then if we multiply it with 100, as you can see, it becomes percentage error. So relative error multiplied with 100 always gives us the percentage error. So mean value, then absolute error, then mean absolute error, relative error, and this is percentage error. Fine. Then there are combination of errors. So now what do we mean by combination of error? So combination of error means, for example, let's say I have to measure the area of a rectangle, for example. So the area of rectangle is always length into breadth. Getting me? So area of a rectangle is length multiplied by breadth. Okay, so if somehow we did some wrong measurement in the length and did some wrong measurement in the breadth. So first we did mistake in measurement of length, second we made mistake in measurement of a breadth. Now because we are calculating area and area has both length and breadth, okay, so the manner in which these two physical quantities they combine or they come together will also add up the error. The error of in length will add to the error in breadth, and the final answer will be incorrect. Okay, so that is what is known as combination of error. How errors in separate physical quantities combine to make a bigger error. That is what it is. So there are two ways in which we look at it. The first way or first method is how the error progresses or error increases due to separate values when two different values are added or subtracted. So that is due to sum and difference. So due to sum or addition of two values and due to difference or subtraction of two values, the error can become greater or the error can reduce or become lesser. Okay, so that is what is known as combination of errors. And the second, obviously we know, multiplication and division. So in two different ways these errors come together. It may increase, it may also decrease. So first method is sum and difference, and second method is multiplication or division. So we will see in today's class sum and difference, how the errors propagate or increase or decrease when we add two different physical quantities or subtract two different physical quantities together. So let's see. the error of sum and difference. So what is this error of sum of difference? When two physical quantities are added together or subtracted from each other, the final value that we obtain, the final result that we obtain, because because these two quantities were also having some error in the measurement, when we add or subtract them, the final answer, that means, will also have some error in it, is this okay. So the absolute error in the final result is the sum of absolute error in individual quantities. Because A and B has error in them, definitely C will also have error in them. That is what is known as error if the two values are added or subtracted. So we'll see an example. Let's say it is C. So C is the final result and C is obtained by addition of A and B. Now we already know that when we measured the length and breadth of a rectangle, there were errors in each value. So we wrongly measured A, we have also wrongly measured B. This wrong measurement could be more. That means if the length of a pen is 7 centimeter, we have measured it 7.5 centimeter. And if the length of a width of a pen is, let's say, 2 centimeter, so then we have measured as 1.8 centimeter, which is less. So it can be more or it can be less. So A and B values that we have measured are wrong. So it is expressed like this. This is the absolute value of A. This is the absolute value of B, but because we have measured it wrongly, it could be plus error in measurement of A and plus the error in measurement of B. But when we are now using this value, when we are calculating A and C, then we can write it like this. So C is what? A plus delta A, that is plus of B plus delta B, because A is nothing but here and B is nothing but this. But when we combine them together, A plus B is equals to delta A plus delta B, we can say that C, absolute value of C plus delta C. So here, as we have done the calculation, this C is never C. Okay, if A and B we have measured correctly, then the final answer will also be correct, C. But here we are using CC, but it is never C, it is always C plus delta C. So we express it like this. So the values that we have measured, the final value also have error, because the initial values or individual quantities that we have measured, they also have some error in it. So I hope all of you understood. Thank you very much. I'll see you in the next class. Any doubts, you can contact me anytime.